kiddos, here we go. Wow. They had some real doozy of a question. You all know what I'm talking about. That question, I think it's number 30. This is June 2019. We got some good ones, we got some great questions, and we got some what the heck was that question? But anyway, this is going to be part 2 through 4. My name's Mr. Krause. You can call me Mr. Key. All of this stuff can be found on my website at mrkrausemath.com. So take a look at it there. By the way, if you haven't tried these problems before you're doing this, shame on you. Go try those problems. Subscribe to my website so you know when I put up some new videos. There's lots of review material over there, but you need to try these problems before you come here and get help from me. All right, those are all the part 1s. Hopefully I did those correctly and didn't make any silly mistakes. Okay, so this one said, let's do the average rate of change from January 1st to April 1st. So January 1st through April 1st. And we want the average rate of change. Now, you guys know that the average rate of change, AROC, is change in Y's over change in X's. Now, this is the average rate of daylight change, and it looks like it's going up about a minute or an hour and something. So let's do average rate of change is equal to 13.9 minus 9.4 all over, now this is 4 and this is 1, so 4 minus 1. Come over to the stupid machine. Hey there, stupid machine. You done gonna help me out there, brother. Thank you. 13.9 minus that there 9.4 all over 4 minus 1. I don't know why I did that, and it's just 3. 1.5. So my average rate of change is 1.5. Now that almost everybody got. And then there's this answer. So that 1.5 goes here, obviously. Interpret what this means within context of the problem. If you didn't use the word average, you didn't get full credit for this. The average amount of sunlight increases. By the way, if you can see this little dark thing over here, I couldn't get rid of this green screen. I apologize for that. I can't do anything about it. Increases 1.5 hours. And I could write on average here. I could write the amount of sunlight increases 1.5 hours on average from January to April. So you had to include January and April, and you had to say it was 1.5 hours on average increases from January per 1.5 hours per month. 1.5 hours per month on average from January to April. There you go. That's how you got full credit for that sucker. All right, so we had a lot of kids not get this one right. So what's the first thing we're going to do is change this to a plus and this to a minus. And then I'm going to look, and I'm going to put this in parentheses, and I'm going to look at them. I see a 4 and I see a 2. So the common between those 4, I have an x and I have an x plus 1. So my lowest common denominator is 4x, x plus 1. So that was what I got to change them all to. 4x, x plus 1, plus 4x, x plus 1 equals 4x, x plus 1. I'm not going to lie, this problem took way too much for a 2-point question. So this already had a 7, this has a -2, and this is a 1. So I got to figure out what we added. We went from 2 to 4, so I got to multiply by 2. And there's a new x plus 1, so that's x plus 1. This one already had the x plus 1, so the new thing is the 4x. And this one already has the 4, but it's missing the x and the x plus 1. So once I have all that done, I just say, okay, now I don't need you guys. And I'll distribute. Now this is 14. So I get 14x plus 14 minus 8x equals, now this is just 1x, so x squared plus x. Now it's easy. Now everything comes to the right side now. So this is, what is it, 6x plus 14 equals x squared plus x. 0 equals, if I subtract 6x, I get x squared minus 5x minus 14. And I get 0 equals x minus 7, x plus 2. So my two answers are x equals negative 7 and x equals positive 7 and x equals negative 2. So those appear to be my answers. I really should check these. I really should grab the old calculator and go, okay, 7 control var x. Who knows? I might have screwed up a sign. One place I screwed up a sign, I got the whole problem wrong. And to this problem, even though I showed all that cool work, I'm not going to get much for credit. So 7 over 2x. And this does not take long. Minus, now I'm going to go back to what the original was. So minus control division 2 over x plus 1. And I never use the equal sign because it's problematic. Oh, equals 1/4. And then I'm going to take negative 2, control var x, and do this again, and I should get 1/4. Okay, they both work. So there we go. There's the answers. Woo, that's a lot of work for 2 points. And then you get this silly question. There's a lot of craziness going on. So if I just graph this, you should know what this thing graphs like, but if I just graph this, control log, I got all kinds of weird answers. 2. This is a log function that moved to the left 6 because it's got a plus 6. So there it is. Now it looks like it goes straight down, but it doesn't. You have to remember, and I said this a million times. 1, 2, 3, 4, 5, 6. This is an asymptote. You can't cross it. You have to get close to it, but you cannot cross it. So now if I go to the table, control T, negative 6 is undefined. See how it's undefined there? But it's negative 5, 0. Negative 4, 1. Negative 2, 2. Any other nice points? 2, 3. And that's the last nice point. So it goes like this. But it also goes down here and gets close to, but does not cross the x-axis. There you go. Full credit. That's it. Believe it or not, that's it. Whatever. All right, here we go. The only reason I need this is for the sign. But I like to draw my bow tie. It just reminds me I'm going to be working with one of these triangles. And since it says quadrant 3, ding, 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 this is the winning triangle. Now, I got to remember that tangent is opposite over adjacent. Opposite, which is 7, over adjacent, which is 24. So now if I do 7 squared plus 24 squared equals the hypotenuse squared. So this is 49 plus was that 576? I don't know. It's late and I'm tired. I think it's 576. 576 equals x squared. X squared equals 625. So x equals 25. So this is 25. Now they want to know cosine. You have to remember cosine is adjacent over hypotenuse. So let's label this sucker. If this is the angle, this is opposite, this is adjacent, and then here's hypotenuse. So cosine of theta is equal to 24 over 25. Now, if you did all that and forgot that all students take calculus and cosine is negative in this quadrant, you missed a point. There we go. Kenzie believes that for x that these two are equivalent. So I want to show or prove or whatever that they are or they are not. So I'm just going to, first of all, rewrite this. And I want to see if it's equal to this. So first I'm going to convert this. So this is x to the 2/7 times x to the 3/5. Does it equal x to the 6/35? Now, it didn't ask me to prove, otherwise I couldn't mess with that sign, but it asked me to show me if she's correct. Now, you have to remember, when you multiply things that have the same base, you add the exponent. So I need to come over to my calculator and go 2/7 plus 3 divided by 5. And I get 31 over 35. So this is x to the 31 over 35. Does that equal x to the 6 over 35? No, she is not correct. She multiplied the, sorry about my handwriting, exponents instead of adding them, or something to that effect. And that's it. That's all she wrote for that one. Man, I had a kid go all crazy on that problem. And here we go. There's the winner. I'm going to stop for a second. I'm going to come back so I have fresh. When I saw this question, I'm like, you got to be kidding me. It actually is a great question, and I'm going to include it on all of my reviews and spirals, and I think it's kind of a cool question. But, man, just coming out of the blue. So when it's divided by x minus 1, the quotient is this. Well, if that's the quotient, I should be able to take these two things and multiply them to get the original exponent. So in other words, what I'm going to do is I'm going to take x minus 1, and this is a very easy question if you understand this. And I'm going to multiply it by x squared plus 7 plus 5 over x minus 1. And now I'm going to show this explicitly. I'm going to take this, and I'm going to multiply it by this. So in other words, I'm doing x squared times x minus 1 plus 7 times x minus 1 plus 5 over x minus 1 times x minus 1, really over 1. So here's what happens. This gives me x squared minus x plus, oh, excuse me, let's try that again. This gives me x cubed minus x squared plus 7x minus 7. And here's where the weird stuff happens. This cancels with this, and it leaves me plus 5. So my answer is x cubed minus x squared plus 7x minus 2. I know. You're like, that's it? You probably spent an hour looking at that doggone question trying to figure it out. No, that's it? Yeah, that's it. It's a kind of a cool question, but boy, just throw it on you. That's crazy. But they gave you a gift here, and I cannot believe how many people screwed this up. A sub 1 equals 6. A sub n equals something times the previous term. How did you all forget to put this in? All you got to do is figure out what the ratio is. What is R? R is 9 divided by 6, which is 3 halves or 1.5. So that's it. There's the answer, of course, without the arrow. I'm not kidding you. That's all there is to that problem. You could have done 1.5 times a minus 1, n minus 1. Robin flips a coin, blah, 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 blah. You guys know how to do this. Do the results strong evidence that Robin's coin is unfair? So the first thing we should do is run a 95% confidence interval. So we're going to take 0.499, and we're going to add and subtract 2 times 0.049. So minus 2 times 0.049. 0.401. 0.401. .597. So there's our 95% confidence interval. Now Robin flipped a coin and got heads 43 times. Do we think results simulate strong evidence that Robin's coin is unfair? So Robin got 0.43. So Robin, 43 out of 100 equals 0.43, which is inside our 95% confidence interval. So no, Robin's coin is probably not unfair, or you can write is probably fair, one way or the other, since 0.43 is within the 95% confidence interval. Shabam! Done. That's it, kiddos. All right. Oh my God, I cannot believe this. How does this? I'm just going to do it. 4x squared minus 9, 4x squared plus 9. This can't be factored, but this one can. 2x plus 3, 2x minus 3, 4x squared plus 9. Now, there are 4 roots to this thing. My first 2 roots are going to be x equals 3 halves and x equals negative 3 halves. So the roots are x equals 3 halves and x equals negative 3 halves. They come from here. X equals negative 3 halves, x equals positive 3 halves. But this also generates roots. It generates imaginary roots. And so if you were to just do menu 331, menu, algebra, polytool, menu, algebra, polytools, find the roots of a polynomial. It's a 4th degree polynomial. Do complex, and you do 16, and then negative 81. You get plus and minus 3i, or 3 halves I, plus and minus negative 3 halves I, positive 3 halves I. So you get, no, Sarah is not correct. It is a 4th degree polynomial, and there are 2 real solutions, plus and minus 3 over 2, and 2 imaginary solutions. Plus and minus 3 halves I. And that's it, kids. That's all I had to write for that one. Moving on, children. Oh my God, half-life questions. How does anybody forget the half-life equation? S of t is equal to our starting amount, 200, 1/2 to the t over the half-life time. Remember, this is our half-life time. It's always a half, and this is our starting amount. So then it says, how long will it take to eat 1/10 of its substance? Well, 1/10 of 200 is equal to 20. So I want to know, when is this going to equal 20? So I said, okay, 20 equals 200, 1/2 to the t over 15. Now I'm going to solve for t, so I know I'm going to use logs. So I'm going to divide by 200, and of course this is 1/10 equals 1/2 to the t over 15. So log, it's all about that base. The base is 1/2. Logs are equal to exponents, t over 15. And the 1/10 goes here. Now how do I get rid of that stupid 15? I just multiply both sides by 15. And I come over to the old dumb machine and say, hey, dumb machine, I'm back. I'm back. Here you go, brother. Help me out, man. Help me out. Control log. Base is 1/2, 1/10. And it says 49.82. So t equals 49.8289. How many years is this? T equals 50, because it said to the nearest year. That's it, kiddos. That's all she wrote for that one. All right, so I'm going to do this one 2 separate ways. First way I'm going to do it is by definition, and that's we pick a point x, y. We say, okay, my first distance is equal to y minus the directrix, which is negative 5, or y plus 5. And then I'm going to do the distance between the point and the focus. So x minus 4 squared plus y plus 1 squared. Then I'm going to set those two things equal to each other. Y plus 5 equals x minus 4 squared plus y minus 1 squared. Now, if you square both sides, this turns out to be y squared plus 10y plus 25 equals, now the square and the square root go, but this is still x squared minus 8x plus 16 plus y squared. Now, why are those both minus? Those should not both be minus. Okay, so this one should be plus. I didn't write plus over here. Y squared plus 2y plus 1. All right, now I'm going to solve for y. So the y squareds go. Bring this over. And bring this over to this side. So I end up with 8y equals x squared minus 8x 16, 17 minus 8. Divide by 8. And I get y equals 1/8 x squared minus x minus 1. Now, I can check that, and I'm going to check that right now by graphing it. Graphing. 1 divided by 8 x squared 8 x squared minus x minus 1. Hopefully that's right. There we go. Now I go menu, analyze graph, analyze conics, focus, click on it. Yep, 4, -1. Menu, analyze graph, analyze conics, directrix, click on there, and there we go. All right, so I know that's the right answer. Now I could have done it a different way. I could have done it using the graph. Now the focus is 4, -1. 1, 2, 3, 4, -1. The directrix is -5. So that means that the center, or the vertex, has to be right here, which is at 4, -3. So I could have done it this way. Y equals 1 over 4p. Now take the center of the vertex. X minus 4 plus 3. Now, what is this? This p is this distance between here and here, so that's 2. So this would be equal to y equals 1 over 4 times p, which is 8. Since this is distance is 2, 4 times 2, which is 8. This is squared. X minus 4 squared plus 3. And that would have also given you full credit. Now, you can check that to make sure that is in fact correct. So we'll go over here, we'll go tab. You'll see that it's the same exact parabola as this, 1 over 8 parenthesis x plus 4. It should be minus 4. X minus 4 parentheses squared. You'll see that's going to line right over the top of this thing. Oops. Plus 3. Oh, you see? It didn't. Now, why didn't it? That's because when I put the y value in, I changed the sign. You see I changed the sign? This should not be plus 3. This should be minus 3. So I made a simple mistake, but boy, is that going to cost you. So I go hit tab over here, and I'll change this to a -3, and you'll see that they line up exactly. See how it's lined up all over the other one? That's because they're the same. So there's another formula you can use. You can use that 1/4p stuff, and actually I think I might start using that this year. I mean, my kids got a little taken aback by all that radical stuff. All right, let's talk about Juan and Felipe. Juan and Felipe. So, given the practice time was long. So I'm going to tell you right now, the only thing you're allowed to look at is this. So that means we need this total, 27. Determine the exact in the Krause dictionary says, don't touch your freaking calculator. So what is the probability Felipe wins given practice long? Well, we're only allowed to look at this, so that's our new universe, 27, and Felipe wins is 12, so 12 out of 27. That's that answer. Determine whether or not 2 events Felipe wins and long. So in order to prove this, I need to prove that the probability that Felipe wins equals the probability that Felipe wins given practice is long. Well, I already know this is 12 out of 27. I need to figure out the probability that Felipe wins. So that means I need to do these. That's 18. So if I add those up, I get 45. A lot of kids added up 55. So what's the probability Felipe wins? It's 12 out of 45. So does the probability of Felipe wins equal the probability that Felipe wins given the practice was long? Well, no, those aren't going to be equivalent to each other. They're not even close. So that's not true. So no, they are not independent events. Independent events. Now, a whole bunch of people went with this one. The probability that Felipe wins and long practice is equal to the probability that Felipe wins times the probability of long practice. Well, you could have done this too. Felipe wins and long practice times. Oh, I just screwed up. Oh my God, I just screwed up. I just screwed up. The probability that Felipe wins is not 12 out of 45. It's 22 out of 45. The fact of the matter is, I apologize. This should be 22 out of 45. So the probability that Felipe wins is 22 out of 45. But these still aren't the same. Now, how do I know that? I come over here to my calculator and I go, okay, 22 divided by 45 is 0.48 repeating. And 12 divided by 27 is 0.4 repeating. Does 0.4 repeating equals 0.48 repeating? It does not, so they're not. But I also could do it this way. The probability that Felipe wins and long practice time, that's the 12 out of 45. Does that equal the probability of Felipe winning, which is 22 out of 45, times the probability of long practice time, which is 27 out of 45. And if you multiplied these two fractions, they would not equal each other either. So it is not independent. All right, and then probably the easiest question on the test, I think. So first things first, we're talking about this kid who runs over a tire. Here's the equation. Let me break for a second. All right, so all we got to do is figure out what the period is. Hopefully you've read this by now. I got to figure out, I was gone for like 10 minutes now. We're going to figure out the period. So period is equal to 2 pi over b. Now you got to remember, this is a, and this, whatever's in front of here is b. So this is 2 pi over 0.8 pi. Well, 2 pi divided by 0.8 pi. The pi's cancel. So, what the heck? 2 pi divided by 0.8 pi. 2 divided by 0.8. 2.5. So, my period is 2.5. Okay, now what does this interpret within context? Now, you have a tire. You just got a nail in your tire. Now, the period is the time it takes for the nail to go one revolution around. So the period (2.5 seconds) is the time it takes for the nail to travel one full revolution. That's it. All right, let me write this down. Negative 13 cosine 0.8 pi t plus 13. So A equals 13. B equals 0.8 pi. C period equals 2.5. X scale equals 2.5 divided by 4, which is really 0.625. Not necessary in this problem. My midline is y equals 13, and my max is 13 plus 13, which is 26, and my min is 13 minus 13, which is 0. So since it's a real life problem, I'm going to put my axis here and here. Now, since I only have to do one revolution, so let me count these boxes. 1, 2, 3. I think there's like 20. So I'll make every box 2. 2, 4, 6, 8, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. And I only need 4 tick marks. 1, 2, 3, 4. Now you need to just remember that 2.5 is here. Now you could put the 0.625 here. It really doesn't matter. Now I'm going to come through and do my midline. It's at 13. Now you got to remember that a cosine curve looks like a uterus, according to Miss Newman, or an upside down uterus. But since it's negative, it's going to be upside down. That means it's going to start at a min, it's going to end at a min, and it's going to have a max in the middle, second tick mark, max in the middle. And in between the maxes and the mins, 0, or on the midline. And hopefully your graph look like that. All right, that's the curve. Now let's see what the heck says. Does the height of the nail ever reach 30 inches above the ground? No. The maximum height of the nail is 26 inches. Midline plus amplitude. Something like that. That's it. That's all you had to do. There's the end of the game. All right, kids, how'd you do? Let me know. Hopefully you did okay. Keep studying. Keep working hard. Lots of review at MrKrausemath.com. Please hit the subscribe button and the like button. Let me know what you think. Sometimes I make mistakes. Be nice. My handwriting's terrible. I'm good at math. I'm not great at spelling, and I'm not good at penmanship. But, you know, I try. I'm working on it. And maybe I'll get a better writer someday. Maybe when I get my new house. All right, guys. Catch you on the flip side. Goodbye.